a pleasant morning to everybody.
Good morning, sir.
Wonderful morning, Zahinia. I try to use up the chat as much, guys, because I can see the chat. So if you guys are answering questions in the chat, I can be able to participate with you as well, right? Because once I'm on the screen, it's hard to see unless I have a different device working with. All right. So looking for an interactive class, and I don't think there's going to be any interruption today. Last week we were not able to complete the entire paper, but things happen. Today, rest assured, I'll make every effort to complete this paper. And this is a very good, well, I don't even say a very good paper, but it's as I promised you last week, it's going to be the paper that I got the distinction on. Yes, people, it is my paper. This is the paper that I got a grade 1 in mathematics on. The year 2009. Yes, this is my paper. It's going to bring back some nostalgic memory. Yesterday, I did the paper that I failed. And my students in the face-to-face class yesterday, all of them, they were laughing at me. Some of them, they were laughing at me. How did I fail this paper? Because they thought it was easy. But, everybody can say the thing after the exam has been completed. But today, we're going to be diving into the paper that I got an AAA profile on. And without doing too much talking, we're not going to dive right into it. All right, so officially a pleasant morning to everybody who is watching on all my social platforms. All right, let's get into it. I hope you guys, quick little advice that I gave the students yesterday, right? We are officially, well, pretty much we are about 3 weeks away from the exam. If you stop and think about it. Today's April 19th, so this week and the other week, probably like maybe like 3 weeks to a month left before the exam. So I hope you guys start to pick your questions from now, right? Start to pick your questions from now. Right? Start picking your favorite questions from now, the questions that you like. Remember, we need apart from questions one and two, where everybody else I feel like should be able to wrap your minds around that. You need to start picking at least 4 to 5 major topics that, functions, matrices, trigonometry, statistics, that kind of stuff. Start picking your questions from now. All right. So you can have some level of security. Remember, there are going to be questions on the paper that in that moment and in that time and on that day, in that particular essence, you won't be able to process how to work out the questions at that time. But no one question or no series of questions, as long as you're not too much, can make you fail the exam, right? You just have to ensure that you do enough to get 60 points. And then you go ahead now and you just, deal with the multiple choice as best as you can. And everybody in here, I trust that you would have gotten fairly good grade on the SBA. The target is trying to get a little bit over 100 points. If you can get anywhere between 110 and 120 points, then you're going to be in the conversation. You're going to be in the conversation of getting a pass. So that's the only focus right now, people, is to do as much as you can to get a pass so you can move on with your life. Move on to different things, better things, right? That may not necessarily involve maths. All right, let us start off with a small prayer. We can't do anything without God, right? If involved in some way, shape, or possible, in any way, shape, or form. So, Ms. Gentles, you want to kick off with a short little 1 minute prayer for us, please? Thank you.
Heavenly Father, we want to give you thanks for today, Lord. We want to thank you that we are able to be on this platform as we get in preparation mode for our exams. Some of us have other exams hanging over our head, but we put more into maths because we feel like this is the hardest of all. And so we pray, Father, that you will just touch our brain cells and help that learning will be easy, and that as our teacher teach with such clarity and understanding, that we will leave here feeling confident and that on the day we will perform and do our best. Father, we pray that you will guide us as we go forward and let all things done to the glory and honor of your name. In Jesus' name I pray. Amen.
Fantastic. Thank you very much, Ms. Gentles. So let's dive right on into this. All right. So as per usual, guys, don't ever forget to read the front of the paper and, take 10 minutes or so and scan through the paper, see what you like, see what you don't like, see what may give you a challenge and try to get all of the easy stuff out of the way. Sorry, other way. Try to get all of the tougher questions out of the way so you can smooth the transition through the exam. All right. So you can see here the exam is 2 hours and 40 minutes long. Instructions are to answer. Well, there's more instructions now more than ever, but answer all questions in section 1, any 2 questions in section 2. At this time, when CSEC was about, we had 14 questions that we had to choose 10 from. Now you guys only have 10. Does that make the exam easier or harder? I think it just makes the exam a bit easier. When more options are there, you tend to make more mistakes. All right, so let us kick it off with question number 1. All right, and you're seeing these questions repetitively coming up, so you guys should be getting comfortable. All right, so 2 2/3 plus 1 1/5, all divided by 6 and 2/5. All right, so we have a bunch of mixed fractions to work with here. So we're going to go ahead and we're going to say 3 times 2 is 6. 6 plus 2 is going to give us 8/3. All right, and that's going to be plus 1 and 1/5. So that's 5 1's 5 and 1 is 6/5. And that's going to be all over 5. 6 is 30. And 30 plus 2 is going to give us 32. It's going to give us 32/5. All right. Now at the top, we're required to work something out. So 8/3 plus this, we're going to go ahead and we're going to write that to the side here. I'm going to find the LCM of that. So 8/3 plus 6/5. LCM is going to be 15. 3 into 15 goes 5 times. And 5 into 15 goes 3 times. All right, 5 times 8 is 40. And 3 times 6 is 18. So we're going to end up with 58/15. So this will be the answer for the top section. All right. Now we obviously going to take the answer that we have at the top, which is 58/15. And we're then going to divide that by the answer that we have at the bottom, which is 32/5. All right. So now, because we are dividing 2 fractions, we are going to simply keep the first, change the sign, and flip the last. So we end up with 58/15. And that we're going to multiply that by 5/32. All right, and then we're just going to simply look for something to cancel out. And it's very evident that 5 can go into itself 1 time. And 5 can go into 15 3 times. And we could try 2 here. 2 into this goes 16 times. And 2 into this will go approximately 29 times. All right? You'll figure it out in your own like a timing. 29 times. Second day. 29 times. Give me a second, guys. I don't know why this. 29 times. All right, so our final answer then works out nicely to be 29 times 1 is 29. And that's going to be 3 times 16 is going to give us 48. All right. So our final answer there is 29/48. And they said that we should put it as an exact value. So 29/48 is as exact as we can get the answer, right? There's no need to turn it into a decimal because it did not require us to round it off to any decimal places. Okay. Fantastical. Lovely. All right. Any questions on that one? Everybody Gucci?
Yes.
You guys can use you can use up the chat, thumbs up or so. Just as long as I know you understand, I can assume that silence means that you guys are okay, but a little thumbs up to say, sir, everything Gucci, everything understood so far. That would be grateful. All right. Okay, silence is golden. All right, number 2. We are to find the square root of 0.0256 over 25. All right, so there's a couple of ways you can do this one, right? There's about 3 ways you can do this, right? So what you can do first here, ladies and gentlefolks, is you can go ahead and work out what is inside the bracket here, first of all right? So you can go ahead and work out what is in the bracket. Just a minute for me, guys. Give me 1 minute, guys. I think somebody does not have the link for the class. Give me a second. Give me a second here, guys. Okay, but the first is it. All right, so we can go ahead then and we can work out what is in the bracket first. Go ahead for me, guys. I'll work that out for me, please. What is 0.0256 divided by 25?
$1.024.
No, try again. Something. 1 point? No, I think that's no.
$0.00.6.
Right, I see Antoine is telling me that it's 0.0010024, which is very good. All right. And then you can just go ahead now and find the square root of that number. And then that would be, even though it's worth 3, okay, so we have to put it in standard form. So go ahead now and find the square root of that number, please. So 0.032, all right? 0.032. Now, that is only 1 mark. We now need to put this in standard form. Now, how do we put a number in standard form? If we can recall that to put a number in standard form, you must move the decimal point between the first 2 numbers or the first 2 non-zero digits. Let me reiterate that. In order to convert a number to standard form, your task is to move the decimal point between the first 2 digits that are non-zero. And the only 2 non-zero digits that are there is 3 and 2. So our job now is just to move the point here. So we're going to move the point here. 1. Oops, sorry. Where did I get a circle here? So 1, 1, 2. Putting it right there. So by moving the point there, we're going to end up with 3.2. All right. Standard form is going to be times 10. Always times 10. And then now we need to raise that 10 to a power. Now, what power do we raise it to? Is going to depend upon the direction that we move the point and how many places did we jump. Now, it's very obvious that we jumped 2 places. But is it negative or positive? Well, the rule is that if we jump to the right, then it's going to be negative. And if we jump to the left, it's going to be positive. So you have to remember those little things right there, okay? So if we jump to the left, it's positive, and if we jump to the right, it's negative. So obviously you can see that we jumped to the right, so that's going to be 2 negative. So the answer is going to be 3.2 times 10 to the negative 2. All right? So that is one way of getting to your answer. If you wanted, you could have gone ahead to find the square root of 0.0256 all divided by the square root of 25. So you could have split the square root, right, if you wanted to work it out that way. Traditionally, and well, an average student is just going to simply work out what they see. All right, so they're going to probably work out, do it the way that I did it, right? But other students who have an understanding of splitting square roots, you could do just that there. Okay, and you would have still end up with 0.032, and then you do your thing and you get to your answer. All right. Any questions? Everybody is okay? Everybody is okay?
Yes, sir.
The calculator look like something wrong with the calculator.
What is happening? Is it
Because
giving
I'm not getting, when I use the phone, I get what is there, but
you?
I'm not getting that on the calculator.
So the calculator has actually programmed in standard form. So that's going to be something I'm going to show you how to deal with. I know what is happening to you. When you type in those big numbers, your
Yes.
calculator is programmed not to produce too many decimal places. I think there's a feature that you have to change on it. So whenever you're dividing
Okay.
like a decimal number by a whole number, that's going to give you a whole lot of decimal numbers. That usually comes up. I know what is happening there though.
And it is giving me something to the minus 0.3.
It's actually programmed to give the answer in standard form when there's too many decimal places.
That's why you tell me 1 point something.
Yes.
All right, so here we go.
Something to -3.
Yes, that's what I'm getting. But when I use the phone now, I get the thing that's on there.
Yeah.
All right, so here's what I want you to do for me. I want you to, all right, so for those who are getting that kind of, well, it's not an error, it's just how the calculator is programmed. Do this for me. Clear your screen, right? Put the square root, open a bracket, and type that number in. Everything as you see it there, and then close the bracket. So put the square root, open a bracket, type in the 0.0256, all divided by 25, and then close the bracket and press equal, and tell me what comes up on the screen.
0.032 Pani now.
0.32? What you get?
Yes, that's what I get to.
0.32?
0.032.
0.0. All right, so hold on now. So you get 0.032, not true?
Yes.
Good. So move the decimal point now. 1, 2, and you see you get 3.2 times 10 to the negative 2. So what is happening is that because you didn't insert the bracket at first.
Okay.
So you just have to understand your calculator and know how to manipulate it. All right?
Okay. Yes, thanks, sir.
You're most welcome. All right. All right, so Kishin says she's good. All right. I'm assuming that everybody else who is silent have no questions, no concerns. So may I move right along. The basic wage earned by a truck driver for a 40-hour week is $560. So the basic wage, so let's underline some keywords here. The basic wage, give me a second here, guys. Why my stuff is, okay, good. All right, so the basic wage, keyword here, basic wage of a truck driver for a 40-hour week is $560. Keywords here. All right, understanding what basic wage is. All right, so just as a reminder, ladies and gentlefolks, basic wage is the amount of income that one receives at the end of a particular week or fortnight. 40 hours is a standard amount of hours that almost everybody in the government system works, because you work 8 hours a day, 9 to 5, and you're supposed to work 5 days a week naturally, excluding Saturday. So obviously 5 days in a week, 8 hours a day, that's 40 hours. And for this basic truck driver, he's getting $560 for that week. Now, we want to calculate how much he's getting hourly. Now, as I was talking to you last week, ladies and gentlefolks, that pay attention to the weight of the question. Pay attention to the weight of the question. The weight of the question will tell you if it is that you need a lot of working out. So this one is just going to see, if you want to write a formula, you can, but you don't need to, right? You can just common sense it out and be like, okay, then you can say that the hourly rate is what we call the basic rate. So our BR is going to be equal to 560 divided by the amount of hours worked. Naturally, because you're going to divide the money that you collect by the amount of hours where you work to get that money, to know how much you are being paid per hour. If you want to go ahead and be fancy and do all of this extra writing for 1 mark, that's entirely up to you. You don't need to do that. So what is 560 guys divided by 40? Sound like 14.
Yeah, 14.
So $14. Right? And that's it. $14, 1 mark. So if you want to go ahead and say, oh, basic rate is equal to basic wage divided by basic hour, if you want to do that, you can. All of that is totally unnecessary, right? You're not going to get any extra credit for being articulate. All right, $14. Very good. All right, now, next question says, for the overtime. So this is now key now, for overtime. And what do we mean by overtime, guys? Overtime refers to hours work beyond your 40 hour. So as long as you begin to go over 40 hour, ladies and gentlefolks, if you begin to go over 40 hour, any time over that is going to be considered to be overtime. And once you work overtime, you are going to be paid at a slightly higher rate. Now, according to this question, the driver is going to be paid 1.5 times the basic hourly rate. So you have to learn to read with interpretation, guys. So the driver is going to be paid 1.5, 1.5 is 1.5, right? So 1.5 multiplied by the basic rate. All right? So you have to remember them two things there. Now you have to calculate his overtime for 10 hours of overtime work. Now this is not very challenging at all, because think about it. If I work 10 hours overtime, right? And I know that normally I am being paid $560, but because it's overtime, I know that for those 10 hours, I'm going to be paid at time and a half. Then I have no math to do. That's it. What is 10 multiplied by 560 multiplied by 1.5? How much is that?
$8,400.
Pardon me? How much?
8,400.
Can somebody confirm and make sure that we are on the right path? 8,400? Somebody can confirm? Oh, yes. Calda has confirmed. 8,400. Lovely, good. Lovely, lovely, lovely. That's it. That's the 2 marks. That is the 2 marks. Now, this is the part that I was hoping that this comes up. Now, here's some keywords. I want you to pay. I see what CSEC does, or what every examination body does, is they tend to put certain words in bold, or they put it in all caps. So you see them something here, when you go on the exam, you see them do it. It is a key part of it. So it's a clue. So here's what they say. They're saying, calculate the total wages earned by the truck driver for, this is the key right here, 55 hours. Many students get caught by this. Okay, someone is in the waiting room.
Mr. P,
Yes, go ahead.
no, go back on the paper.
Okay. Yes, JD, go ahead.
How we get 8,400?
JD, we multiplied it. See, it's on the screen.
I know that, but probably make me either go or something.
No way you ask me, say.
If his hourly rate is $14, I make $14 hour.
Oh, so you're right, though. Oh, my
Oh,
God.
then the 14 plus 7, then they add that to the 560.
So we make a mistake, though. Because thank you so much, JD. The 560 here, Miss Gentles, is what was given to the driver every week. Oh, my God. That was
Right.
such a bad mistake. Thank you, JD. We make a mistake, Miss G. Yeah, man. So the 560 so yeah, that's very good. Thank you. How did I miss that? I think I got caught. I was thinking too much. Oh my Lord. Thank you. Thank you very much, Jada. And I head I go man, my own I go. So it is 10 hours multiplied by the 14 per hour. Thank you, Jada. Multiplied by 1.5. Very good, Jada. Very good. Excellent. Good to spot an error. All right. Could we recalculate for me, please?
210.
210. Very good. I thank you very much, Jada. All right. Sometimes we get lost in the calculation. And these little mistakes can happen to anybody if you're not careful. All right. So back to the question now. Calculate the total wages earned by the truck driver for this 55 hours. So this is the part now that I want you guys to pay close attention to. I was hoping that this comes up. I don't like when they make the question too easy and then throw you off with a question. All right. So 55 hours. So what is the normal hours that this driver is supposed to work?
40, anything over is overtime.
And therefore, then, if you work 55 hours during this particular week, what is that? What is that extra hour called?
OT.
Overtime. So we know that for him to work 55 hours, he would have had to work his regular 40 hours, not true?
Mm-hmm.
So we know then that he would have to work his. So how much would he be paid for that 40 hours?
The same 560.
560, very good. So he'd be paid 560. All right. Plus now, we know he's going to be paid. We know he's going to work an additional 15 hours, not true? Which he's going to still be paid what? $14. So it's going to be 15 times 14. Give me a second, guys. So 560 plus 15. Give me a second. So 560. I don't know why this keeps coming back. Hold on, give me a second, guys. Why does it keep coming back? Save the erase content first. Erase content will not display after you save the document. I don't know why it keeps coming back. But anyways. All right, so 560. All right, that's for the 40 hours, not sure. And then now he's going to work an extra 15 hours. And we know he's going to be paid his usual $14. But because it's overtime, he's going to be paid at 1.5. So we're going to put this part in a bracket here. So 560 plus, go ahead and work out that for me, guys. What is 15 times 14 times 1.5?
$315.
$315, very good. And then if we add that together, we're going to get $875. All right, $875. Okay. All right, is everybody clear?
Yes, sir.
All right, Calda says good. That is good. All right, I'm assuming, I'm going to assume that everybody else who is not leaving a thumbs up or saying something in the chat or not speaking to the microphone, I'm just going to assume you're clear. Because if you're not communicate with me, I can't know if you're lost or you're not lost or you're not asking me anything. So I'm going to move on with that assumption. All right, lovely. All right, so we take care of that question. All right, so quick. As I told you guys, I feel like everybody in here, regardless of what CSEC do, you guys will be able to capitalize on at least 9 out of the 12. Or if a 9 marks it worth, you guys will be able to capitalize 7 out of the 12. All right, so let's move to question 2 now. And again, as you can see, for the last 4 marathons, this has been quite prevalent. No matter which people we take up, we always see one factorization. So yesterday, and all the other marathons before, I've always listed out the different types of factoring technique. Now we have 4 types of factoring technique. I'm going to once again go ahead and list them out for you. HCF method, grouping method, difference of squares method, and then we have the quadratic. These are the 4 techniques. You have 1 month to get used to this. We've done this in regular class. We've done this in extra class. We've done this in marathon. There's almost not more that I can do, guys, to help you to remember these steps. You have to practice them, because if you don't, you're going to get lost. You're going to still get them wrong, even after working them for a year. All right. So which method do you think is number 1?
Group it, sir.
It's grouping, and you can confirm this. How can you confirm? Yes, Geneva, it's the grouping method. How did you confirm it's the grouping method? What is it that gave you that impression?
There is nothing really repeating.
The 4, they have 4.
It are 4 terms, that is correct. 4 terms. And Jada, you said there is nothing really repeating. There is, because if you put this and this together, then something I repeat in another bracket there. And if you put this and this together, then something over this I repeat. So I get what you're saying. There's not really anything repeating right throughout. But the confirmation for why it's the grouping, Jada, is the fact that it has 4 terms. Check your notes from yesterday that I gave you. 4 terms confirm that it is a grouping method. All right. So now that I put those 2 in a brackets, right? Let's go ahead now. In the first bracket, what is it that you see repeating itself?
A.
Very good. So you're going to pull out the A. So pull out the A. Open bracket. Now when you remove when you factor out the A from the 2AX, what is left?
2x.
2x.
Very good. All right. And then, hold on, let me just, don't like how this is looking. Yes, that's right. All right. So you're saying now when we factor out the A from the 2x, there's a 2x left. All right, cool. And when you factor out the A from the 3AY, what is left?
3y.
3y, very good. All right, what is over there? What's repeating on the other side now?
B.
Very good. B is repeating. So factor out the B. When you factor out the B from the 2bx, what is left?
2x.
Very good. And then obviously when you factor out now, watch this now. You see the negative here times a negative, I'll give you 1 positive. All right, and when you factor out the B from this 3by, what is left?
3y.
Very good. All right, so now we have 3y left over here. All right, now even without thinking too hard, guys, if you notice that when we're doing this, always what is in this bracket always comes back in this bracket. So you shouldn't even be calculating the second bracket, because if the second bracket wrong, you can't go further. All right? But anyways, these two terms are what we refer to as common terms or like terms. Well, not like terms, but they are like factors. So we're going to go ahead now and extrapolate those. 2x plus 3y as a common factor. And obviously now, if these two are common, then what is left after you take out the common terms?
A minus B.
Very good. A minus B. All right, so you have the minus B here, I have the A right here. Okay. All right, and that is it. All right, any questions on that? Everybody clear? All right, silence is golden. I like that. Once you not talk, everything good. All right, lovely. Fantastic. Like that. All right. I've seen Alicia, Geneva, Calda, and Antonia. Kishane only in the chat. I see Aria 1 or 2. Well, I see Aria once. Need to get more communication from you guys. Because if you're lost over one party, you're not talking. I can't help you if you're not talking. If you're not asking for going over or, sir, how you get this again, the assumption that I have to make is that you guys are as clear as mud. Okay. All right. And I of course, I hear Miss Gentles in the microphone and Jadia and Zahini and stuff. So, all right. Number 2. Which method do you think is number 2? Which technique you think is number 2?
Difference of 2.
Difference, I don't see difference of 2. That's a good guess.
Square.
8CF.
It's 8CF. All right. I'm gonna make up on mind. Which one do you think? Me here 8CF, me difference of 2 squares. Colors in difference of 2 squares. All right, so my question to the persons who say it's a difference of 2 squares, what number would you square to get 20? Or you want to change your mind? Because if it's a difference of 2 squares, you can't have a common factor.
Change.
Calder changes his mind. Antonia says 8CF. Gents, you change your mind?
Yes.
Yeah, you have to change your mind, because if it's a difference of 2 squares, you cannot have a, well, it's not that you can't, you can. It can be a combination. But you're not completely wrong, Miss Gentles. It is a difference of 2 squares, but it's combined with something else. So first, as Alicia says, you have to take out the common factor first and then see what is wrong. So you're not wrong, Miss Gentles. You're partially right. Your answer is just a bit too early. So let's factor out the 5 first. All right? Because the 5 is common. Now, if I factor out the 5 from 5x squared, what is left?
X squared.
Very good. And if I factor out 5, how much lots of 5 can I get from 20?
4.
4. Now, Miss Gentles, this is the part now that you were referring to. This is the difference of 2 squares. Because now, unlike 20, where there's no number that you can square to get 20, there's a number that you can square to get 4. So this now is going to become 5, open bracket, x squared minus, and then 2 squared gives me 4. So now you can go ahead and do the difference of 2 squares. All right. So remember, guys, you're going to have combination questions as well. You have to keep your eyes peeled for that. All right. All right, good. Now, what is the steps that we take when we are putting a number into difference of 2 squares?
You open
two brackets.
one
So
to
what if you open 2 brackets, giving them, and
One
then
with
what
a
now?
plus and one with a minus.
One with a plus and one with a minus. I hear you, JD. I hear you. I see the practicing coming through. And then what now? What we're going to do with each bracket? Okay, Geneva, I see your answer already.
going to divide and share. So
Share them, not divide them. Share them. So x here and x here. And then, me get what you mean by divide. Oh, you're going to throw. Okay, I get what you're trying to say.
yeah.
2 over here and 2 over here. All right, and that is it. So your final answer then becomes 5 open bracket x plus 2, close bracket, open bracket x minus 2. All right? All right, good. I'm getting a different vibe from you guys. I'm getting a different vibe. I don't know. I've not gotten this vibe in the last 3 marathons. I've gotten a little bit, but I'm getting a little bit more. I can sense that you guys are starting to recollect the information. But let us see as the paper goes along. All right. Remember, guys, this is nostalgic for me, you know. So you're bringing up what that feeling I got when I got that distinction, you know. So help me to pass back this exam again. Let me see if I know how to pass it. All right, lovely. So what do you think the last one is now?
Quadratic.
And you can
Quadratic.
confirm this. How? How do you know it's quadratic? What makes you say that?
It has a square. It has
That's
a number before the variable, and it has a constant.
excellent. So it has a square term. It has a term with a square. It has a term without a square. And it has a constant, as Jadia rightly said. All right. So just as we did before, 3x squared plus 4x minus 15. I'm assuming that you guys remember 3 times 15. That's going to give us negative what? 45. Not true? We'll split this now. Split that. Give me some numbers I can multiply to give us 45. Calder, I'm seeing your chat. I'm hearing. If I don't call your name, just know that I'm seeing what you're saying in the chat.
9 and minus 5.
Or you want to go? I would just, well, for the purpose of the class, we want to list out everything. All right? So that everybody can fully understand. So yes, I see person saying, give me the answer right away. But let's start off with 1 and 45. All right? 15 and 3. And then, as you rightly said, 9 and 5. I rather to list them out so a person can see how we're doing it. We're not just picking random numbers, because some of you guys are a little bit more advanced than others. So you guys may be able to see it faster. But remember that the number in the middle may not necessarily be 4. What if it was 12? What would you choose? If it was 12, what would you choose?
15.
What if the number in the middle was 12? What would you choose?
15 and minus 3.
Good. And what if it was 44? What would you choose?
45 minus 1.
Good. So you want to ensure that at all times you list out all the factors so you can confirm which one. So right now we can confirm that it is not this one and it is not this one. It is exactly 9 and 5. Now, how would we produce 9? How would we get a 4 using the numbers 9 and 5? What would we have to do to the 9 and the 5? That is correct, Wines. You're going to make the 9 positive, and you're going to let the 5 be negative. All right. Lovely. So we're going to put those in the middle now. So we're going to say 3x squared. All right, 3x squared, right? And then now this 4x now is going to be replaced by the 9 and the 5. So you can put the plus 9x here, and you can put the minus 5x here, and then you can put the minus 15 here. All right. Good. So now that we have that spread, now notice that 9 and 5x is still 4x. So I really haven't changed the expression. All I've done is that I've just expanded the expression so that we can put them into groups of 2. All right? So talk to me now. I'm going to put these into groups of 2 here. And this into groups of 2. So that brings us back to this example that we did up here. Grouping. So you see that we're getting 2 grouping questions in one. All right, so common factor here now. In the first bracket, what and what is it that you see is common?
3.
Always check. Pardon me? 3. Calder, you're correct. 3x. All right. Now, once I've factored out the 3 and I've factored out one of the x from the x squared, how many x's is left? Correct, Geneva? 1x, 1x. All right. And if I factor out, how many lots of 3 can I get from 9?
1.
1 lot of 3. So 1 3 is 9?
3.
3. How many lots of 3 can I get from 9? 3 lots. And I've already factored out the x. All right, now on the second bracket now, what is it that I can factor out? Correct again. Calder and Geneva, senior active in the chat. All right, so that's negative 5, open bracket. When I factor out the negative 5 from the negative 5x, what is left? X, Matisse, I see you too. You're jumping into the chat, that's good. And X plus 5 into 15 goes 3 times, all right? But again, as I tell you guys, if you want to step it up at least 2 seconds faster, whatever is here, guys, it has to be here. Because if it's not, you can't go any further, right? So our final answer then is going to become these two that I've underlined in red are the common factors, so that's X plus 3. And then now the remaining factors is going to be what? 3x minus 5, all right? And that's it. Fantastic. So we'd have cut up 6 points quick and fast, right? And when you're doing it, it's going to be faster, and it's just because I'm teaching and I'm explaining. But when you guys are doing it, you're going to be moving way faster, probably like a minute or 2. All right, so clarity, everybody? Everybody Gucci.
Yes,
All
sir.
right. Everybody Gucci.
Sir.
Lovely. Yes, question. Yes, go ahead, I'm listening.
Sir, I think the person just said yes, sir.
Oh, okay. And Kishin is good as well. All right, lovely. Good. All right, lovely. Good. All right, so now we're going to look at a worded simultaneous equation. Worded simultaneous equation. 1 pack of biscuit costs X dollars. And 1 cup of ice cream costs Y dollars. Now, here's the biconditional statements. 1 pack of biscuit and 2 cups, let's underline what we have. So 1 pack of biscuit and 2 cups of ice cream, right? So the word and in mathematics means to add. Make sure you remember that the word and in mathematics means to add. So 1 pack of biscuits and 2 cups of ice cream cost $8. While means 3 pack of biscuits. Again, the word and means to add. 1 cup of ice cream costs $9. Your task for 2 marks is to write a pair of simultaneous equations in X and Y, meaning that the equations must involve X and Y, that could possibly represent the given information above. So that's not too difficult. I feel like everybody in here should be able to do this. So let's see here. I'm going to go down here. So we're going to say then, all right, the first situation was, also, now we know that what? A biscuit is represented by X and an ice cream is represented by Y. And we're told that 1 biscuit, so that means X biscuit plus, remember the word and means to add, and 2 cups of ice cream. And that's 2 ice cream will cost you $8. That becomes equation 1. All right. And then now we end up with the second biconditional statement that says while 3 packs of biscuit, so that's 3x, all right? And remember the word and right here, and means to add, and 1 cup of ice cream, that's 1y, that's going to cost you $9. And that is going to be called equation 2, all right? So here, all right, good, very good. Asinia Calda, very good. Antonia, very good as well. $9, right? Perfect. Both of you guys are correct. Carly, you don't need to put the 1 in front of the X. All right? X there means that the 1 is understood. Not that it's going to harm you in any way, but I mean, it's totally irrelevant. All right. Now, again, if you forget how to work a simultaneous equation, then, working, I mean, this is just, doing that is just 2 marks now. So if you're in the exam and your brain freeze up and you'll be like, how am I do this again? I don't remember. Don't get frustrated. 4 marks cannot make you fail the exam, right? 4 marks cannot let you fail the exam. So don't stress about it. All right, so let us recall now. So for those who forget all about this, take some notes, do some jottings, do some something. Right? So here's what we're going to do, guys. Our job is to choose. Well, not even choose. Don't choose. You know what? Just go right ahead and try to make the numbers right here and right here the same. But the only way to do that is to basically multiply the equation down here by this number and multiply the equation up here by this number. I don't want to confuse it. Hold on, let me just remove that. All right. Since as we're trying to make the numbers or the coefficients of the variables in the middle the same, the number that is in front of the y at the top, multiply the bottom equation by that number. So what I'm going to do is that I'm going to multiply equation 1 by 2. Sorry, equation 2 by 2. So why I do that? Because there's a 2 right here. So I'm multiplying the equation at the bottom by 2. But since there's a 1 right here, right, I'm going to multiply the equation up here by 1, which is kind of, wouldn't say redundant, but it's totally unnecessary. When you multiply something by 1, you're going to get by the same thing. But we're going to do it for the purpose of learning. All right, so go ahead. 1 multiplied by everything up here will give you back everything up there. It is gone. Okay. So we're going to have 1 times x. That's going to give us, so we're going to say now, what y'all going now, guys? So we're going to say now 1 times x. So 1 times x is x. 1 times 2y is 2y. And 1 times 8 is 8. And that becomes equation 3. All right. Then 2 times 3x is going to give us 6x. Lord have mercy. Separate what's going on with you today. 2 times 3x is going to give us 6x. And first equation is the same second in multiplying by 2. Not sure if I understand what you're saying, Geneva. 2y equals 18. And let me just double check and make sure something good. 1 times that, 1 times that, 1 times that, 2 times that, 2 times that, 2 times that. Okay, so that's equation 4. Okay, I did 30. All right, good. All right, now what's the rule now? The rule is if these two numbers are the same signs, so if these two signs are the same, rule is same signs subtract, different signs we add. So since the signs are the same, they're both plus plus, we're going to subtract the equation. So we're going to end up with a minus here, a minus here, and a minus here. So what is 1 take away 6? That's negative 5x. And what is 18 take away? What is 8 take away 18? That's negative 10. All right. And so therefore, x now has to be equal to negative 10 divided by negative 5, which works out nicely to be $2. And you know, say I'm money I deal with, so there's no way you could possibly get negative 2. That would be unrealistic. All right. So that is 2. Now, once we've gotten the value of, so because x is 2, what we're simply saying then that is 1 pack of biscuit is costing $2. So now it's time to find the cost of an ice cream. So we're then going to go ahead now and we're going to substitute. So we're going to substitute. I'm going to substitute. Why is this looking like this? Oh, Lord. Yeah. All right, so we're going to go ahead and we're going to substitute. Two for x. And choose the equation. It doesn't matter. Anyone, equation 1 or 2. It no matter which one you want to choose, you can't get it wrong. You get it wrong only if you compute incorrectly. So I'm just going to choose equation 1. So substitute 2 for x. Two for x in equation 1. All right, so we're going to say 1 plus, come here, put the 1 right also. So 1 plus 2y, that's going to give us 8. So 2y is going to give us, oh no, it's not. Oh, it's 2. Okay, I'm substituting 2 because I'm wondering why am I getting a decimal number. So it's 2 actually, guys. I'm substituting 2 for y in equation 1. So 2 goes here, right? So it's going to be 8, take away 2. 2y will give us 6. So therefore, y is equal to 6 over 2. Y is equal to 3. All right, so $3. So therefore then, 1 ice cream will cost us $3. All right, everybody clear on that? Everybody Gucci? Seen this for the first time? Or you've seen this for the first time in a long time? Make your notes, make your jottings, and we have time to grasp this. We have another month or so. We have another 2 or so classes to grasp this. All right, good. No questions. Kishin is clear as well. That's good. Now, this question is no longer on the syllabus, so we're going to skip out that. Don't even need to look at it because we're not going to do any sets. It's pointless to even look at it. Showing you will be irrelevant because it's not going to be on the exam. All right. And so construction, you're going to need, this is something that you're going to need your protractor for. So we're going to also X off that question as well. All right. We don't need to do that question any at all.
Will that one be on the exam?
Construction is something that will pop up now and again. Yeah. But that's something that I have to physically show you. It's not something I can use the tools that I have on the screen to do. All right, so just ignore question 3. I might just replace that question 3 with a question 3 from a January paper or something. Maybe like, maybe if the class allows me later, then I'll replace that question 3 with something else. All right. Now, I'm happy that I see this question because this question doesn't come up a lot. It does come up a lot, but then I don't really get a chance to like teach it. Right? So it's reading maps, map reading. All right, question 4. The table below shows 2 readings taken from the aircraft's flight record. Now, looking at the table, we're seeing here where there's a time, which is 800 hours and 55 minutes. Sorry, yeah, it's 800 hours and 55 minutes. And then we have 900 hours and 7 minutes. It's army time. So hope you guys know how to read this. The 0 in front of the 8 and the 9 suggests that it's in the early morning. And we're told that the distance here is this and this. All right. So the question then is, observing the table. For the period between the time of the 2 readings, you're to calculate the distance traveled in kilometers. And it's just 1 mark, so it's nothing heavy. So the distance traveled between the 2 readings is just going to simply be 1,083 minus 957. All right. How much do we get? Talk to me now, guys, so this takes so long. 127. I want to try that again.
126.
126. 127. Let me see.
126.
126. Okay. 126. 126 what?
Kilometer.
Correct. And that's it. That's that for that. Now, average speed. So about 2 or 3 times now, I think we buck up on the use of speed. What's another word for speed? I think I used it yesterday. Start with R.
Rate.
Rate. So just in case you see rate on the exam, rate means speed. All right. So speed is equal to, as Antoine said rightly in the face-to-face yesterday, distance divided by time. All right? So the distance is what we have. We were just told that the distance is 126. The time is what you need to figure out. All right? And the time is in minutes. But speed is also in kilometers per hour. So some conversion. Notice how much marks it work, guys? 3 marks. So it's not no divide by no simple number and just go through. No. We first have to convert. First we have to get the time that it took to move from here to here, and then convert that time to hours. All right. So can you confirm how long did it take for the aircraft to move from 957 kilometer to 1083 kilometer in terms of minutes? 12 minutes. Everybody confirm 12 minutes? So 12 minutes is what it took. So the question now is, how much minutes make an hour? Good, so we're going to divide this by 60. So 12 minutes make an hour, we're going to divide this. We're going to divide the 12 minutes that it took by, because we need to convert it to an hour now. So if you divide 12 minutes by 60 minutes, you're going to get how much hours it took. So what is that in terms of decimal? 0.2? Is there any more digits behind that? Okay, so 12, so 0.2. So 0.2 hours. That's what it took. So just going to simply divide this by 0.2 hours. Just in case anybody's here asking, sir, what if I did this? What if I said 12 into itself one time and 12 into this 5? No problem. You could have also said 126 divided by 1/5, which is basically going to be 126 multiplied by 5/1. You're still going to get the same answer as you have here. So what is 126 divided by that? It is 126 divided by 0.2. So that is 630. 30 what? 630 what?
It's flat, 630 kilometers.
Kilometers per hour. If you leave off that kilometer per hour, you're going to take off half a mark.
Sir.
Yes, Miss
Can
Jensen.
you get the 12 minutes?
Oh, they told us right here. Oh, sorry, not told us. We calculated the distance between the time between here and here. (8:55) and 9:07.
Okay.
All right, lovely. All right, good. All right, no questions. Everybody good to go? Hold on, by the way. I wonder if anybody's in the waiting room. I mean, I know. Oh, Denisha. So he is okay. All right. The map shown below is drawn to scale. This is not very usual, because normally we use the question that says not drawn to scale. So the map below is drawn to scale, and the scale is going to be one. So you see this thing here, so learn to interpret what it means. This thing right here, guys, what it means is 1 centimeter on the map. When them say drawn to scale, on the actual paper, you can only measure by centimeter. So when you see 1 to 50,000, what it means is that it means 1 centimeter on the map represents 50,000. And in this case now, we're talking about kilometers. So 1 centimeter on the map actually represents 50,000. Let me write it down, 1 cm on the map is actually equivalent to 50,000 kilometers on the ground. So when you measure 1 centimeter on the paper, that is representing 50,000 kilometers on the ground. That's what it means. So it's a very large map. All right. Now it says here that we should measure and state in kilometers. Sorry, measure and state in centimeters the distance on the map of L to M. So naturally then, guys, we'd have to go ahead and see this convert to this to here. All right, so can you go on your screen for me, guys? Do you have a ruler? Do you guys have a ruler?
Yes,
Is it
sir.
possible? Go ahead and measure it on the screen for me, please, because it's drawn to scale. So no matter how big, yeah. No question. I think if I remember correctly, and you probably wonder how you remember, I think it's 7.1. 7 or 5.1. If we can't get the correct answer, we're going to have to assume. So hold on there. I'm gonna see if I can blow the P. I can blow it up to like a reg. Let me see if I can blow it up to a regular, right? So this would be what a paper looks like directly in front of you. If you were to have a paper in front of you, there wouldn't be no edges to look at. So measure it from that screen right here. 5.5, right? 5.5. So we're gonna work with. It's now 6. All right. So that means no matter if we blow up the screen, so it'll get bigger and bigger. So let us work with so measure it from here, from this screen that I have now. Measure it from this one. We're going to use that number. We're going to use this number that we're looking at right here. Use a ruler and measure it. 6.1. All right, we'll go work with that. So whatever it is, ladies and gentlemen, when you actually go on the paper, that's the number you're going to use. So 6.1, we're going to work with that. All right, so that's it. So measure and state in centimeters the distance of the map, measure along a straight line. That's it. 2 marks for that. Now it says calculate the actual distance in kilometers from L to M. So going back to our usual thing that we would do, we would say what? If 1 centimeter is 50,000, then 6.1. So 6.1 centimeter is going to be simply 6.1 times 50,000. How much you got? Correct. So depending on what the actual number is, guys, because we can't say for certain if, because I'm on a screen, so if I blow up the screen, it's going to give you a bigger number. So depending on what the actual number is, we just multiply whatever the actual number is on the paper by 50,000, and working with 6.1, the answer is going to be 305,000. Yeah. Oh, hold on. Something right. Something right.
Sir, it's 30. It's 35.
Hold on there.
30,500.
No, say Antoine is right, but I don't think that this means, cause think about it, 50,000 kilometers, that can't right. No, sir, that cannot be right. Something not right. Because from here to Kingston, it's about 101 kilometers. 50,000 kilometers, that's from here to China. No, man, it can't mean that. What I think what it really means, I think I may have misunderstood this now. 1 centimeter on the map actually represent 50,000 centimeters on the ground. And that it mean, So 1 centimeter on the map represent 50,000 centimeters on the ground. So this here is actually 305,000 centimeters on the ground. Now the question is, how do we convert this now back to kilometer? Remember this thing I showed you? Knock him down, man, don't commit murder. And I'm only doing this, guy, because I can just tell you that the answer is going to be, let me see, 10, 100, 1,000, 10,000. So I know I'm gonna have to divide this by 100,000. But it's when I'm teaching, I want to make sure you guys know how I'm getting these numbers. So look, I'm at centimeter right now, and I want to get back to a larger unit. So divide by 10. Oh, sorry. Divide by 10. Divide by 100. Divide by 1,000. Divide by 10,000. Divide by 100,000. So that means I'm gonna have to divide this number here by 100,000. How much you got? All right, so that the answer make more sense to me now. All right, so what gave me the clue? What made me know say a phone is just me and I'm looking down here. How am I getting 50,000 kilometers and I'm looking down, I'm seeing 4.5. So something kind of feel off. So sometimes you're working the question, if the answer doesn't make sense, yes, Antoine, that's what it implies. It actually implies 1 centimeter on the map represent 50,000 centimeter on the, 1 centimeter on the actual map that's on our paper represent 50 centimeters on the ground. And then by converting that to centimeters, we divide it by 100,000 to get our answer. So that's interpretation, right? So questions like these are questions that students are not a big fan of, right? Conversion and that kind of stuff. So yeah. All right. So that's 2 marks. All right. Now, question now. The actual distance. Oh, everybody Gucci? Everybody okay?
Yes, sir.
Good. All right, so the actual distance between 2 points is 4.5 kilometers. So they're giving you 2 distance now. So the actual distance between 2 points is 4.5 kilometers. Calculate the number of centimeters that should be used to represent the distance on the map. All right. So first now, we need to convert back now from kilometer back to centimeter. So if when we were going up, we what? Divided. When we're going back down, we go what? Multiply. So to start off, this is going to say 4.5 multiplied by 100,000. And how much you got? $45,000?
450,000.
450,000. $450,000. You sure that right? So 450,000.
Yes, sir.
Mm-hmm. All right, but that can't be the only thing we have to do to get 3 marks. That is not possible. They wouldn't give you 3 marks just to do that. It said some distance on the map. So first we'll convert the kilometer back to centimeter, right? So then how much centimeter on the map? So how many centimeters should be used to represent on the map? So we want to know the distance. So therefore now, we know say 1 centimeter on the map represent what? 50,000 on the actual ground. So therefore, 450,000 is going to be equal to X. Not true? Because if 1 represents 50, that means that X must represent 450,000. So cross multiply now. X times 50,000 is going to give us 50,000 X. And then 1 centimeter times 450,000, that's 450,000. You see, what makes me know what I need to do, guys, a lot of the times, you see, the weight of the question tells me exactly what I need to do. So it tells me, say, no, so hold on, if I this alone to get 3 marks, why did I have to do so much marks to get 2? So that means it tells me that there has to be something else to the question. So x must be equal to 450,000 divided by 50,000. How much you got, guys?
Nine.
Very good. 9 centimeter. All right, so this is 9 centimeter. And that's it. That is it. So I feel like, yeah, this whole conversion, this part I think is worth 1 point. This part again, I think is worth 1 point. Setup. And then the working out is going to be worth the other point. So that's how you get the 9. But yeah. Jenny bet wasn't done. Yeah, man, she don't know. Yeah, 9 points. All right. What we guys feeling? Feeling good? Body okay? All right. All right, lovely. Moving on. Our favorite question. Tell me, class, I love that question. Eh? When I started teaching, so on the face look. When I started teaching this topic, you see on the face look. I just a minute, guys. Somebody wants the link. Give me a second. Give me a second, guys. All right, good. All right, lovely. Now, I'm back, guys. Given that f of x is equal to 2x minus 5, and g of x is equal to x squared minus 31, we're to calculate the value of f of minus 2. How do we approach this question? Anybody?
Substitute the x values into the equation.
Substitute, go again, say it again.
Substitute the x values in the table into the equation.
In the table, we don't reach the table part yet. Up here, there.
Oh.
You're gonna put -2 wherever you see x.
Correct. In which one of the functions?
The f function. Yeah.
So that's going to be, so go ahead, JD, and finish it then.
So it'd be 2 bracket -2 take away 5.
All right, and that works out nicely to be -4 minus 5 equals -9. The person who spoke about the table, I'm going to need your services when we reach down there, because you're not wrong. It's just that you're working a different question than what we are working. So you're not wrong. You're perfectly correct. We just not reached this yet. All right, good job, JD. All right, number 2, who wants to take on that one? Anybody, same person, JD, if you want to take it on, you can. G of f of 1. What do we do? How do we interpret this one?
Is it where you put the ones in the f function and you get the answer, you put it in g?
That is absolutely correct. So first we go ahead and we say f of 1. So we go ahead now and we say f of 1. So we're going to go ahead and say 2 times 1. Sorry, guys, give me a sec. So 2 times 1 minus 5, and that's going to end up being 2 minus 5, which is equal to minus 3. So that is f of 1. And you can put that back into G now. So you're going to end up with now minus 3. Put it in bracket G there. Don't forget, because if you go on the question and lift off the bracket, you're going to end up under the pressure. You're not going to remember, say, when you square something, you're going to work with what the calculator tells you. So don't forget the brackets. Minus 3 squared minus 31. So that works out to be equal to positive 9 minus 31. And I believe your answer works out nicely to be negative 22. All right? Everybody okay with that? So this part right here is where we put the 1 into the F first. And then this part down here is where we put the answer back into G. Everybody good?
Yes.
Everybody good?
Yes,
Gentle?
sir.
Okay, good. Can? All right. Zahenia? Antonia, no, okay? All right.
Yes, sir.
All right. Julia cussed me yesterday about this one. But no shortcut. That you say. Okay, all right. So you say no shortcut.
No.
No shortcut. No shortcut. All right. So this one means what? F minus 1 means what?
The inverse.
So we're going to let y equal to the function, which is this one, because that's the inverse we're finding out. That's the function we're finding the inverse of. Interchange x with y. So x are equal to 2y minus 5. And then our objective is to isolate y. So to isolate y, we're going to bring over the 5. We're going to get x plus 5 equals 2y. And then we're going to obviously divide both sides by 2. Cancel that. So x plus 5 over 2 equals y. Now, here's the thing that I want to constantly remind you guys about. Is when you find y, that's not your answer. Your answer is when you say, therefore, f inverse x equals x plus. Yeah, so some wicked markers out there. They might have a point to prove to students. And I feel like they're hired to really make students work hard. So you see, for safe reasons, you see, after you find y, please, may I beg you, draw the conclusion and say f inverse of x equals x plus 5 over 2. They will take off half mark. There's no point in losing half mark when I've done all the hard work and all I'm going to do is forget under the pressure set to write f inverse x. So please make sure after you find y, make sure so you go back, go say f inverse x equals the answer. Now remember, don't forget the 3. Remember, I said this f inverse to find. So f inverse 3 is equal to 3 plus 5 over 2, 8 over 2 equals to 4. All right? Perfecto. Good? Lovely. All right, now back to my student that was earlier. Given that y is equal to this thing here. So remember, whenever you get a quadratic, it is going to either be this curve or it's going to be that one. Anybody remembers which one it is? How do we know if it's smiling or frowning? I think we discussed this week. How do we know if the graph is first of all, is this graph smiling or is it frowning? Not that we care, but just as a prediction, if it's negative or positive, if what is negative or positive, that to be very specific. If what is negative or positive. If x value, but we don't know what the x value is at the moment. Oh, the coefficient of x squared. Be very specific. So the graph is smiling because the number right here, so let me zoom it up. Number right in front of here, so is positive. It's 1. So that's how we know it's smiling. All right. Not that we care for this particular question, but in the future. So copy and complete the table below. X, Y, negative 4, 5, negative 3, negative 2. Yeah. So as the student was saying earlier, that we're going to put the minus 3 into the function here and here and get the number that goes here. Okay? So remember that now. All right, so we're going to work it out. It's 2 marks. You have to show working. So we're going to end up now with put minus 3, put in minus 3 here and here. So Jadia, once again, minus 3. Don't forget to put it now on bracket because under the pressure, I tell you, whatever the calculator tell you, it you go write down. You not stop to think about that. You saw the adrenaline is there, and you feel so confident. You know so at this you're supposed to do. Whatever the calculator tell you, you're just going to work with it. So be careful. Whenever you square anything, remember say a positive. All right. Plus 2 times minus 3 minus 3. So that's a positive 9. If you left off the bracket, it's going to tell you negative 9. And when you try to plot the curve, you got problems. Minus 6 minus 3. 9 minus 6 is 3. 3 minus 3 is 0. So 0 goes here. And next one is going to be 1. So we're going to end up with 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3. 3 minus 3 works out to be 0 again. All right. Good. Now here we must say now. Using a scale of 2 centimeter to represent 1 unit. That means every 2 squares on the graph paper, you're going to write down 1. So every 2 squares represent 1. And on the y-axis now, every 1 centimeter represents 1. So it's 1 to 1 on the y and 2 to 1 on the x. And I'm going to make this frighten you, right? Because when I was doing it, I tell you, I never understand what this means. Me never understand when none of them something you don't necessarily mean. I just remembered what my teacher tell me, and I just did it. Is couple years, is maybe like a year after, or like 2 or 3 years after, I really understand what this meant was just the width of the graph. In fact, all this means is that the graph starts at minus 4 and ends at 2. It is what we call the domain or the width of the graph. So we don't know what when you see something funny, and you see something funny when you never see before, Mr. Pierre don't teach you, because I don't usually miss. Right? I'll make an odd mistake here or there during the process of working out, but usually everything that is on the CSEC paper, I usually explain to every single one of my students if you've attended all my classes. All right, so it says on the graph, we're going to use that scale. All right, so let's go here. Here's our graph. Oh, we were supposed. Oh, yes, I remember, guys. When we were doing math at this time, we were given a special graph. Sorry, we were given a separate graph. Nowadays, you guys are given the graph in your booklet. So now I have to go ahead now and sketch up my graph here. All right. So let's see here. Hold on, guys. Hold on.
Mr. Beard,
Yeah.
please.
Uh-huh.
Asking to be let in.
Who?
Gabby, her iPad died, so she's using a different device.
Oh, okay. All right, so look at the scale now. So what this means now is that every 2 So every 2 represent 1. So I'm going to go as far as 2. So every 2 represent 1. 1. Now what? I can make it go wider. So every 2 centimeters. So 1, 2, that's a 1. 1, 2, that's a 2. 1, 2, that is negative 1. 1, 2, that's negative 2. 1, 2, that's negative 3. 1, let's see here, 1, negative 4. Now for the y-axis, now I just go by 1. The highest number here is 5, so I don't need to worry. So 1, 2, 3, 1, 2, 3, 4, 5. I don't see negative numbers. Oh yeah, this is a negative 4, so I need to go down here. 1, 2, 3, 4, 5. All right, so we have all my numbers now. I have everything now. Hope you guys are following. All right, so first point now. First point here is going to be negative 4, 5. Negative 4, 5. So I'm going to go across negative 4 and go up 5. Oh, let me number these. 1. Oh, Lord. Where did it go?
Sir, no 2, 4, 6, you number the X across.
2, 4, 6.
Yeah.
It says 2 centimeters to
2.
represent 1. So every 2 squares from a skip is 1.
And the other one? Oh, you
1
did
to
the other one.
1 to 1.
1 to 1?
Yeah. All right. So I'm thinking that maybe negative 4 and 5 will meet somewhere out here. Somewhere there. So no. I know. Let me try see if we can. I see the line here. Don't do it, please. Please don't do that line. Me I beg you. Don't do that. All right. So I hope you get the idea. I guess I can plot it by myself. Because I don't have a graph per se to guide me. So I'm just going to make some little guesses. I'm going to put mine there. So negative 4, 5. That's my first point. What's the next one? Negative 3, 0. So negative 3, 0 is on the line. Right here.
Negative 2, negative 3.
Negative 2, negative 3. So that's negative 1 down here. Negative 2 down here. Negative 3 down here. All right. So negative. Is it negative 2, negative 3?
Yes, sir.
How about somewhere else? Let me see. Let me see. So when I don't have a graph, it's kind of hard. I kind of like these exam papers from the other day where you actually have a graph coming up, you know? I'm going to put it right here. What was the next point now?
Negative 1, negative 4.
Negative 1, negative 4. So negative 4 is right down here. Right here, so. Next one.
0, negative 3.
0, negative 3. So 0, negative 3 is on the line right here. Next
then
one.
1, positive 1, 0.
Positive 1, 0 right there, so.
Positive
Next.
2, positive 5.
Positive 2, positive 5. Somewhere so. Not accurate, but you know the idea. You get the idea. All right, and then we're just going to just simply connect this to this here. So I've got like a perfect thing they are going through, you know? Yeah, so not perfect, but you guys, if you guys do it, you guys will be much more perfect than I am. All right, everybody good to it? Everybody Gucci?
Yes, sir.
And I'm trusting that everybody here, if a graph is placed in front of you, you can drop your scale and do your thing and plot your point and angle yourself. All right, lovely, perfect. So we are done there. All right, that's it. That's it for that. All right, moving on to faster because remember, guys, it's 14 questions on the paper. Let me scroll up and show you what I'll go on. It says 14 questions on the paper. It's not like this year where it's 10. It's 14. So when you see we look like we are moving fast, we're not really. And a fast way of move is just that there's a lot of questions on the paper. So there are 12. Oh yeah, we're going to X out this one. This long it's no longer on the syllabus anymore. Earth geometry. Now it's mad them time then. And we have vectors around here, so we have matrices and stuff. Right? So we are hoping, let me look at the time now. 10:53. Let's see if we can do 2 more questions and take a break at 11:30 now. Right? So we add questions what now? 6. Let's see if we can let us see if we can do this one and do the statistics, and then wherever we stop at the statistics, we can take a break from there and come back at 1 hour after the time. Yes? How me sound? Everybody good with that?
Yes, sir.
Yes, sir.
Perfecto. Lovely. All right. And I trust that everybody is going over the recordings in their own little time during the week. Do like a 1 hour, do like a 2 hour. Make sure you tap them up, guys. Right? Right. Every question. Remember, know favorite questions. Know favorite questions. You guys know what questions you favor. So put a lot of effort into working and cementing those questions in your brains. So when you're sitting question upon the exam, woof, woof. Woof, woof. Everything else after your favorite questions is simply going to be consolation prizes. Extra that will inch you closer and closer to getting that grade 1. But you need to make sure you have 6 solid questions. 6 questions on an exam is 54 points. All you need are 6 more to meet the class target. So if you can get all of the statistics right, all of question 1 right, all of question 2 right, functions right, that are 4, right? You can get a little bit of the matrices right. You can get a little bit here and there and there. You just want the points to accumulate to anywhere over 60 points. And believe me when I tell you guys, rest assured, without a shadow of a doubt, you would have defeated majority of the high school students that are doing maths for the past 5 years. It's a strategy I use. Not no bright business, no who bright and who can work. Nobody cares if you do the whole paper or not. Because a person who, in fact, on this paper, I rest assured, I tell you, I only remember doing 6 questions on this paper. Out of the 10 what I was supposed to choose. So I'm going to say 4 questions out of this I had absolutely no idea how to do. But how did I get an AAA profile? Okay. I'll leave that analysis to you. The diagram below shows triangles ABC. Sorry, the diagram below shows triangles A, B, and D, and it also shows the line y equal x. JD, you remember this? You remember this? That we did yesterday. Y equal x, where I said it has to go through 1, 1, 2, 2, 3, 3. You see it? So you see, we were supposed to draw it yesterday. Now you see this one now. Them draw it for you. I remember yesterday's paper was what? 2008 May, June. This was what? 2009 May, June. So 2008 they allowed us to draw it, and 2009 they drew it for us. That's how it go. Oh, give me a second, guys. Excuse me, I'm so sorry. Give me a second. Somebody wants to get into the class. Zahinia? Zahinia got kicked out. Oh, it was just calling. Okay. Okay, she's back. All right. So for those who were at the face-to-face yesterday, can confirm that we actually got this paper. So remember, guys, when you're drawing the line y equal x, you can't just draw one line straight through the middle. It has to go through 1, 1, 2, 2, 3, 3, and as long as you get 2 points, you're good. Now, just in case, you say them ask you if draw the line y equal negative x. This is the line that is negative x. Sorry. So if them ask you to write negative x, this is negative x. Negative x is still going through what? But this time negative x is going through what? Negative 1, 1. Negative x is actually going through 1, 1, negative 1, 1, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. So just in case them flip the script on you, and we are so accustomed, we don't want when them write y equal negative x, to be like, Mr. Pete never teach me this. It's just the other way. The line is turned the other way. All right? So please make a note of that. The line is turned the other way. All right, let us see what they're saying now. What are they saying to us now? Describe fully. So in our last marathon, online marathon, we looked at this description thing. We had a very elaborate discussion of how to describe a transformation. And we looked also at how the marks were allotted, what to mention. Sure you guys can confirm on that. So let us see if we can. So describe fully the single transformation that maps the triangle A onto, the first one was D. What caused A to go onto D? What do you think it is, guys? And how do you know what you think it is? Talk to me, guys. How do you know what it is? A onto D. We discussed it yesterday. Check back your notes that I gave yesterday. How do we know when a transformation takes place?
Is it translation, Mr. Peart?
Why you say that?
They look identical to me.
Correct. You are correct. That's all you need to know. It is a translation because the object and the image are identical. Please write that down, ladies and gentlefolks. Because I have students that were here yesterday but are just here online, so I have to give them the notes as well. So write this down now. There are 4 types of transformation. We have translation, right? We have reflection, we have rotation, and we have an enlargement. All right, and as Jada was saying, that when it's a translation, the image and the object are identical in appearance. So identical appearance. They're at a different position on the graph, but they look exactly alike. With a reflection, they are also identical, but the difference is that they are identically opposite in appearance. So it's like them turning back to each other. Our top becomes bottom, bottom becomes top, left becomes right, right becomes left. So they're identically opposite. With a rotation, we know that there is an essence, or not even the essence, there is a feel that something like it turned. So there's a turning effect. And everybody in here most can predict when something turns. And for an enlargement, which is the easiest one, is either something gets magnified or it gets reduced. So it's either the object shrink or the object gets blown up. Please make note of that, ladies and gentlemen. It's in your notes in your book, about. The book full of too much notes right now. We don't need the book right now. What we need is just some little folder leaves and some stuff to write down some stuff and put them in a one box and say, okay, then remember these, remember that, remember that. Studying from your notebook right now is not healthy, right? Because that full of too much clustered notes. You have got to skip through too much pages. You need some little one folder leaves with some little sticky notepads. You need a little notepad, a little notebook that has some formulas that you know are not going to be on the exam. So you just stuck that in your back pocket, and anywhere you go, you're probably sitting in the doctor's office or you're sitting in the waiting room somewhere, you pull out a little notepad and just occupy your mind. Run back through the formulas them in your brain. So that's how you have to do it. Walk with the math. Right? This is how you put yourself in a strong position to do well. All right, here we go now. All right, so as Julia rightly said, A onto D is a translation, but how do we describe it? Write this down for me, please. Triangle A maps on to triangle D. Triangle A maps on to triangle D. Triangle A maps onto triangle D. Describes a translation. Describes a translation. Describes a translation by the vector. By the vector. All right. So now we need to figure out the vector. What caused A to reach up a D? And as we suggested yesterday, all you have to do is just pick one point. Either pick this point and see how this point lands back onto that point. How did that point land? Because they correspond, you know. This correspond with that correspond with that. So pick any one of those those points there and see how it got onto it. So question is, how did the one on A land onto the one on D? How much did I have to go across? And how much did I have to go up to get to that position?
4, 3.
4. You have to tell this 50, right or left?
4 across and 3 down.
4 across, meaning 4 to the right or 4 to the left?
4 to the left.
Left, so you go then. Is that where you're going to get to here?
Sir, me use D and start from the right, go over to the left.
No, but not D to A. The question says A to D.
Oh. Okay.
So it is 4 to the right this way. That's all. So 1, 2, 3. And as before now, then, so and a 4 or 3. 3 to the right and what? 1, 2, 3, 4 up. So 3 to the right and 4 up. All right.
Sir,
So
because me did it from D to A, come never read the question.
Right. So it's not A, it's not D to A, it's A to D. So triangle A back to D. So you're gonna write, so by the vector 3, 4. And you write the vector like this: 3, 4. Write it downwards like that. All right, Ms. Gentles, how you stay? I know this is not your favorite topic, you know. But how you managing?
Who tell you that, sir?
Oh, you like it?
Yes, man.
Oh,
Good.
Okay. I know. I have some students that graph and them, boy. Graph is like leaf of life. Tastes bad. Them not like it, none at all. Even though I make it clear, them still not like it. Them on the graph thing just no see, no plant gunga like. All right, good. So 3, 4, everybody go through with that. So A and D describes a translation by the vector. 3, 4, I'm not sure why they gave us 3 marks for that, because nowadays a 2 they might give you. 1 to say it's a translation, and 1 to say what the vector is. But I guess this 3 marks was for the description. So I guess that 1 mark was for the actual wording, and then 1 mark for the vector, and 1 mark for saying that's a translation. I know. What is causing A to land onto B now? What caused A to get back onto B? What do you think?
I think it's a rotation.
Not think. It is a rotation. It has to be. There's no way that this could be a reflection, because with a reflection, them not identically opposite. Them identical, but they're not opposite. So it has to be a rotation. But no, remember what you have to mention for the rotation. You have to mention Anybody remember what you have to mention for the rotation, by the way? Let me ask first.
Clockwise or anti-clockwise?
As you have mentioned the direction.
The
right?
direction, yes.
What else?
So
2 more things.
Oh,
you mentioned 2 of them already. Sorry, you mentioned that's the rotation. You mentioned the direction. We have to mention something else.
The degree. Degree, Asanya?
Well,
Like if a
the
90,
direction
180
is,
degree.
yeah, that's a part of
Or-
it, but there's something else you need to mention. It's called COR.
Center of rotation.
Center.
Yeah, center of rotation.
Center of rotation, yeah.
Yeah, so you don't want to lose no 1 mark because of that. So write this down for me, guys. Triangle A maps onto triangle B. Triangle A maps onto triangle B. Or if you guys not hear me respond in the comment section, it's because if you guys are talking to me, it's because my device jump off. Sorry. Maybe Geneva was in the comment section. Hold on. Oh yeah, man, Miss Geneva and Antonia. And Antonia, yeah. And Shantana was talking earlier too. Okay, yeah, I see you guys now. All right, so triangle A maps onto triangle B. Describes a rotation. That's 1 point. A rotation of, no. How do you know what the angle is? You say if you move from 1 quadrant to the next, it's 90. 1 quadrant, 2 more quadrant, that's 180. 1 quadrant, 3 quadrant, that's 270. So how many quadrant did A move through to get to B? How many quadrant did A have to jump through to get to B?
Clockwise, it's 90.
Clockwise, it's 90. Very good. Anti-clockwise is what?
Anti-clockwise, it would be 180.
Well, let us see now.
Or 270.
1,
If I work it out.
1, 2, 3. 180 or 270? Which one?
270.
270. So it depends on which direction you want to write it. So if you're going to say 90, you have to say clockwise. So we're going to work with that one. All right. So triangle A maps onto triangle B, describes a rotation of 90 degrees clockwise. Of 90 degrees clockwise. About, and now you need to find the center of rotation. Anybody recall how we did this last week?
You draw a line from one point to the next.
To the corresponding points, not true?
To the corresponding point, yes.
All right. So the question is what this correspond with? The question is what does this correspond with?
Point and the other one.
Right, so? All right,
Yes.
so. The first one?
No, the first one.
Okay. Let us draw a line now. So hold on, did this not feel right? No, sir. Also, I don't like how this feel at all. All right. So where the next one correspond with now? Where this correspond with now? This point right here, so which one point 8 correspond with? The one at the bottom or the top?
The top.
Top one. All right. Correspond with that, no, so. All right. All right. So let us do that. So now, this is a little bit tricky now, you know. Because what's going on here now is that we forgot to bisect the line here now. Oh, Lord. Because now, well, you see how you normally do this here? When you draw two lines, if it's not being rotated from a central point, you have to bisect the line. So this one's kind of a little bit challenging. If you bisect the line here now, bisect the two lines them. So let me see here. So okay. Let me see. Make sure see them corresponding. That correspond with that, that correspond with that. Yeah, we're gonna bisect them two lines here now. Alright, so let me see.
I'm sorry, you couldn't draw the third line.
No, if you draw the third line,
And
it now go. You think
it
so?
will cross one of them, it will cross the N one.
You think so? Alright, let us see now. Oh, alright. Alright, Miss Gentles, alright, so I like your connect. So hold on, wait. Flick a bit. Boy, Miss Gentles, like you're right, you know. So it look like it a connect right here, so. Right, a phone, so. Everybody in agreement?
Yes,
okay, cross
sir.
this up. Alright, so I guess it's been rotated from 4-0.
Yes.
It looked like it's rotated from 4-0. Alright, Shantana say yes. So she's looking at that then, 4-0. Alright, so just drop on that. So about 4-0. And remember now, you're not going to write 4-0 downwards now, you're going to write it like that because it's a point. So 4-0. Okay. Alright, welcome to math class. So these things that we're doing here are the difference between somebody who passes math and fails math. Knowing these little things, this puts us and separates us from the pack. All right, next question says, state the code. Everybody good? By the way, everybody okay? Carl does say yes.
sir.
Everybody good.
Yes, sir.
And you have the recording, can watch. You can always go back over it again. Lexi? Lexi?
Yes, sir.
Oh, you just joined.
No, sir, I just joined.
Okay. State the coordinates of the vertices of triangle C. So there's no triangle C. You have to go figure it out now. So state the coordinates of state the coordinates of the vertices of triangle C, which is the image of A after a reflection in that line. Jadia, can you tell us what happens when an object gets reflected in the line y equal x? Do you remember what I said yesterday?
I think it's going to be y, x, you flip them.
Correct. Very good. Very good. You flip them. So all the positions here, here, and here, those coordinates will be turned upside down. So what's the coordinates of that point right there?
2, 1.
2, 1, very good. So 2, 1. What's the position of this point right here?
5, 1.
5, 1. And what's the position of this point? What's the coordinates of that point right there?
5, 3.
5, 3. Turn them upside down. Now what we get? Upside down.
2, negative.
Upside down. Whenever it's a change sign, upside down. 1, 2. Correct, Geneva.
And 5 and 3.
1, 5. Correct again. And what? 3, 5. No calculation needed, guys. They only say you must draw it. So they say, what are the coordinates? They say you must draw it. State the coordinates of the vertices of triangle C, the image of triangle A after the reflection in the line y equal x.
But just said it work 4 marks, so they just write it down and leave it.
No, sir. You have to work out it. And this is the thing that I was trying to avoid. Because back then you used, as me tell you, maths back then was a little bit more difficult. You had to work these things out. So state the coordinates of the vertices of triangle C, the image of A after a reflection in the line y equal x. That means you're not supposed to draw it, you're supposed to work it out. So get ready, guys. Let me show you what I'll go on now. All right, so when I get a point, Jadia, and everybody else who is logging in, right? So zooming up here. So when you have a point, xy, and it gets reflected in the line y equal x, and it gets reflected in the point in the line y equal x, as Jadia says, it's going to become yx. Now the question is, how many y's is up here? Sorry, how many x's at the top? How many x's at the top? You see the x at the top?
No.
0. How many y's at the top?
1.
All right, how many x at the bottom?
1.
And how many y's at the bottom?
0.
So therefore, this is what we call a reflection metric. So the reflection metric, and not so hard nowadays, guys. So don't worry yourself. This I'll show you. So the reflection metric is going to be 1. Sorry, it's going to be 0. Reflection metric is going to be 0, 1, 1, 0. And we have got times that now by the points that we had up here. What was them? 2, 1, 5, 1, 5, 5, 3, 2, 1, 5, 1, 5, 3, 2, 1, 5, 1, 5, 3. All right, and then you have to go row by column. So back then at this video, for the row by column matrices. So 0 times 2 is going to give us 2. Sorry, 0 times 2 is 0. Plus 1 times 1 is 1. Column now, 0 times 5 is 0. Plus 1 times 1 is 1. Next column here, 0 times 5 is 0. Plus 1 times 3 is 3. We're going to go this row and 1 down this column again. 1 times 2 is 2. Plus 0 times 1 is 0.
Sir, is
Yeah,
you know,
you want to see up the top?
No, what you're working out is
No.
not. You have 255.
A 5 1 and 5 3 hour. It's 5 1 and 5 3 now. 2 1 5 1 and 5 3. But remember, say Miss Gentle's been a teacher, make you see it in an online class now. So probably maybe you see kind of like a bit lost, maybe, or maybe you know it.
Yeah, maybe.
Okay. So 1 times 2 is 2. 0 times 1 is 0. 1 times 5 is 5. I think online class is the only one that hasn't learned matrices as yet. So bear with me. 1 times 5 is 5. Yeah, I haven't taught it any at all, so I'm not reached there yet. That's what's coming up next though. 0 times 3 is 0. Everybody is supposed to know this though, because I've taught them. So when I work this out now, 0 plus 1 is 1. 2 plus 0 is 2. 0 plus 1 is 1. 5 plus 0 is 5. 0 plus 3 is 3. 5 plus 0 is 5. So I saw come know from up here, so say the answer will become 1, 2. See it here? 1, 2, 1, 5, 3, 5. But then I saw 1, 2, 1, 5, 3, 5. 1, 2, 1, 5, 3, 5. But it's because I only show you guys the shortcuts, you know. So we know is back then our teaching. Sorry, my teacher was rigorous. We weren't allowed. Nobody could show us the shortcuts back then. We had to work out to get the answer. Right? It's just years after that I found out that there was a shortcut. Right? I always watch my teacher and see him move fast, and I want to say, how am I do that? How is he? How is he? How does he know this without working it out? So I've always been an inquisitive student since I was very young, especially when it comes to math.
If
So,
I use a shortcut, I'm only getting 2 marks.
I mean, no. The thing is that nowadays they're not really asking to do this.
Okay.
Nowadays they're just asking to draw what the shape is, and it has been consistent for the past decade. So they've stopped asking students to kind of work it out. They're not giving as much marks as before to the working out, because as the years goes by, so to speak, the way how them structure the questions are not as what it was before. You want to see some papers from in the 1990s. My God, you have to wonder if people sit down and actually do this to people. Yeah, man, it was rough, man. It was rough. All right, but that is it. Because remember, JD, 4 marks, So if in your head you know set to go flipping, but you can't explain how it flip, you're not gonna get any marks. You're only gonna get 1 mark for the answer. If in fact them structure the question this way. All right. But that was it. That was it for that question. All right. So you're gonna have 1 and 2 odd questions here or there that will strike your balance. But remember, we have 40 dash points, right? 40 dash points. So you have 40 points on the exam that you can throw in a bag and be like, all right, you know what? I'm not today. And next time for you, my friend. Next time for you, I'm not today. Me learn how to work it out one at a time. But I don't know. All right, last question before lunch. An answer sheet is provided for this question, which it was at the time. All right, so the table below shows the time to the nearest minute that 80 students waited to be served at a school canteen. All right. Now, again, none of my online students are, I don't think any of my face, except for my day school students like Alicia and Shantana. A couple of you girls have already been exposed to this, should have been exposed already. So these things over here are called class intervals. They're called class intervals. All right. But you guys will learn it eventually. So what this means is that 4 persons. So the table is about what? The time waited to be served at the canteen to the nearest minute. So it was observed that 4 students waited 1 to 5 minutes to get through at the canteen. 7 people waited 6 to 10 minutes. 11 students waited 11 to 15 minutes. 18 persons waited 16 to 20 minutes. And you get the idea. All right, so over here is what we call the frequency. And over here is what we call the cumulative frequency. And over here we call them the class intervals. All right. First question says, copy and complete the table to show the cumulative frequency. So as I was explaining to some of the students about the cumulative frequency is adding up the total as you go along. Now notice here that this number and this number is the same, right? But look at this numbers, gentles. Look at this pattern. Do you notice that 4? Do you notice that 4? Sorry. 4 plus 7 is 11. You realize that? And 11 plus 11 gives you 22. You see that pattern? Everybody seen that pattern?
Yes, sir.
So what do you think would go across from the 18?
22
Correct.
plus 11 to the 8.
Yeah, man. They mean that the chat beat your bad, Miss Gentles. Yeah, man. Them over the Shantan and Geneva and Anthony over there, so that's a fly up answers. All right, continue. Well, Miss Gentles, I'm here roll. Let me move too fast. They didn't gone already. They gone the next one. Come, Miss Gentles, I'm here. I'm not pay them no mind. 40 plus 22 is what?
62.
Yeah, man. Then gone the next one. They almost done the whole thing. 62 plus 10 is what?
72.
Mm-hmm. I race them over there, race now. Watch them. 72 plus 5. 77. And 77 plus 3 is 80. Yeah, man. Me over there, so them in that chat. Just click on the chat section, you see them over there. All right, so that's 80. All right, so that is how you fill out the cumulative frequency. All right, good. So that's easy. On the answer sheet provided, use the values from your table to complete the cumulative frequency curve. Use your graph. Okay, so technically then, guys, I would have to do this curve for you. All right. So I think they would have given, well, the paper was given separately. It's not like nowadays where they give you the booklet. But when I was doing math, I had to, we were given a separate booklet that we had to write our answers in. So nowadays I'm giving you the booklet. All right, so now, oh Lord, what is this? It's all right, Mr. Peart. All right, I'm looking at this number and I'm probably thinking that they may have used, I don't know, 10 maybe. Oh no, sorry, I wrong something I draw. It's supposed to be an L curve. All right. I'm gonna do my best, guys, to improvise here. So bear with me. All right, so I'm gonna guess that they are probably using, looking at the scale, they're probably using 1 centimeter to be 5, 2 centimeter to be 10. So I'm gonna just make up one scale then. So right here, so gonna be 10. Oh, sorry. So right here, so gonna be 10. Here, so gonna be 20. It's gonna be 30, 40, 50. I don't know how far did it go? Hold on. Or 40, the highest it go. All right, so we're good then. That's fine. All right, and then up here, so now, obviously the highest number is going to be 80. So I'm going to assume that this is going up by 10. I have to work with me because I have a lot of space. So 10, 20, 20, 30, 40, 50, 60, 70. Work with me there, guys. Work with me. 80. 10, 20, 30, 40, 50, 60, 70, 80. Work with me. Just see if you can balance out the thing one type of way. All right, so what are we going to match now? Look at what we're matching now, guys. What you're matching now, how to plot the curve now, is to match this thing here. So we're matching this number here with these numbers over here. 5 match with 4, 10 match with 11, 15 match with 22, that kind of thing. All right, so 5 with 4. So 5 will go there in between 0 and 10, so that's a 5. That's a 5, and 4 is going to be maybe somewhere down here. So we're not quite sure about this. When the on the graph is going to be more accurate. So 5 with 4. Because there's 10 spaces here. So you have like 9, you got 9, 8, 7, 6, 5, 4. You know, you get the idea there? And you do like that. So you're gonna be on the graph. You guys can try it on your own. Get a graph, right? So I'm just gonna assume that is 4. Next one is going to be 10 to 11. So 10 to 11. 11 is just going to be like maybe like one place above this. So about this or somewhere. No, sir. It bad, Mr. P, but that bad. Some of this, sure. Yeah. I'm not bright people here, man. We'll figure that out. 15, 22.
Next one, 15, 22.
Oh, you can see them, Miss Gentle, so I'm not bother move up and down.
Yes, me take a pic, so you don't have to move
Okay.
up and down.
Okay. So 22, 15, 22. So about this. So some of this. So 2022. Yeah, continue.
2040.
20, 40. 10, 20, 30, 40. So right across. Yeah, so. Yes, continue.
1562.
25, 62.
2562.
25, 62. 25, 62. So 10. So throw me off, so hold on. 20, 30, 40, 50, 60, 70, 80. All right. So it's a 62, 25, get it right?
2562. Mm-hmm.
So about 25, 62, something about this. About this. Not accurate, but or maybe about this.
3072.
30, 72. Some of this, yeah?
3577.
55, 77. Some of this,
4080.
40, 80. That's about right, this. All right. So now we just use our curve now on this. Something like that. Something like that we all get. All right? So you guys can do it on your own and test it out. But it's more or less going to be something like that. All right? So these are the points right here. This so. And with the other point gone. 15 to what? 15 was to what, Miss Gentles? What was 15 to? 15 to 22. So many this so. This so. Right so. Right so. Right so. This so. All right. Good. Lovely. So do that on your own and then confirm. But it says use your graph above to estimate the median of the data. So last week we would have discussed this. Well, not discussed because I'm not a teacher yet, but Q2 is equal to n plus 1 over 2. So Q2 is going to be the number of persons in the survey, which we know is 80 people. And 80 plus 1 divided by 2, so that's 81 divided by 2. The median is going to be at 40.5. So the median is at 40.5. So the 80 persons in the survey, so 40.5, maybe just like a bit here, so all right, accurate, remember. So you guys have to, so based on this graph that we're using here, I'm getting the median time is going to be maybe about 80 minutes. So it's not going to be accurate from what we're doing here. But from my graph of me draw, I'm getting 80 minutes. 18 minutes. Median is the middle term. Right? It's 2 marks because you get 1 mark for draw something on the graphs. 80 minutes. Okay? Based on what I have on screen. I wish I had a graph though. All right. It says that the number of students who waited no more.
Sir,
Yes.
could you repeat how you get the 18 minutes?
Oh yeah. We added the number of students is 80 plus 1. That's the formula n plus 1 over 2. 80 plus 1 is 81 over 2, which is 40.5. So we just use the graph and find 40.5, run it across till it touch the curve, and then just carry the line come down and see it line drop right in front of 20 years. So 15, could be 17, could be 16, just depends on the accuracy of the graph. Okay?
Okay, sir.
All right. The number of students who waited no more than 29 minutes. Again, my graph is not accurate, so it's very inconclusive. So 29 minutes, we'll just go ahead.
Sir, where you gone? We're not hearing you.
Sir, we are not hearing anything, so we're gonna just go for lunch and come back.
Wait, you guys, are you guys hearing me?
We're hearing you now, sir.
All right, I'm gonna go for lunch now because I think my device needs to restart.
Okay, sir.
All right, then. All right.